move on to the next question in 2015. In the context of modern scientific research, consider the following statements about IceCube, a particle detector located at South Pole, which was recently in the news. So obviously it is sourced from current affairs, right? First statement is, it is the world's largest neutrino detector encompassing a cubic kilometer of ice. It is a powerful telescope to search for dark matter. It is buried deep in the ice, right? Now, which of the statements given above are correct? All right. So before looking at the answer, let's understand the concept that was asked. So IceCube is a neutrino observatory and it is designed to detect high speed. Okay, remember high speed or high energy neutrinos. Now, what are the statements given? Let's understand them. It is the world's largest neutrino detector encompassing a cubic kilometer of ice. Yes, this is correct. It's located in Antarctica, that is the South Pole, near the South Pole, and it consists of thousands of sensors. I'll show you the sensors embedded in a cubic kilometer of ice. So the point is, this observatory has sensors buried in the ice itself. It is located at the South Pole, like I said, and was completed in 2010. Second statement, it's true. See, the primary reason is to detect neutrinos, but it is also used for detecting the dark matter indirectly, right? All right. Third statement, buried deep in the ice. Yes, it is true. It is placed deep within the Antarctic ice with the sensors located between 1.5 to 2.5 kilometers below the surface to minimize the interference from other particles and detect the neutrinos more efficiently or effectively. So this is the observatory. So at the surface of the ice, there is a thing called ice top here, as you can see, this one. So this is the observatory, or rather it is the laboratory, right? Now under the ice sheet or the surface, there are sensors. These are the sensors. There are 86 strings which are 125 meter apart. So the distance between them is 125 meter, right? So this is the ice top and this is the deep core. So there are 86 DOMs. DOMs is basically digital optical module which has sensors, right? So IceCube is also called the South Pole Neutrino Observatory. So do remember this thing because UPSC has a habit of asking through synonyms, right? So it has ice top, it has a deep core, they have sensors, these things have sensors, there are strings which are buried in, but not buried exactly, but they are hanging in the ice and they have drilled a lot of holes. So this is how it works. Now, the question which can be asked, if it actually this thing is in news since past 2-3 years because its second generation is coming up, right? So the thing is, we can't really see or feel the neutrons. So we need a special equipment to understand the behavior, but they interact with ice sometimes, right? And when they interact, they release a blue light, and that is called Cherenkov radiation. This can be asked that what is Cherenkov radiation related to? Because radiation, we usually think it is related to nuclear fission or fusion. So this can be asked, right? And they create, when neutrinos interact with ice, they create a blue light, like I said, and that is detected by the sensor. So this is how the sensor looks. This is the ice. It's like a well that is dug and then the sensors are inserted, right? So the answer is D. And neutrinos, briefly if we see, this is not a concept class, so I'm not going to go in a lot of depth. See, they are all often called host particles because they don't interact a lot. Remember, don't interact a lot. They have low probability of interaction, but they are the most common particle in the universe. They are produced in nuclear reaction in the sun, stars, and anywhere else, right? They do not, the tendency is to not interact, but probability is always there, like I said. Now, there is one critical property of neutrinos that they change into one another. There are type of neutrinos and they change into one another. For example, if a neutrino is coming from the sun, it might change once it has reached the earth. They help us in understanding the standard model of the physics, right? They are called leptons. They are part of leptons rather, and there are 6 leptons. Leptons. 3 main leptons are electrons, muons, and tau particles, and they have associated neutrino, right, and an antineutrino. And why neutrino? See, the thing is, they have very low probability, right, of interaction. Hence, when they are released from the source, we are able to, if we are able to interact and catch their or observe them, we can determine the source property, right? Let's see. The other cosmic rays, they are made up of charged particles, right? So because of which, when they pass through other celestial bodies, their the magnetic effect of the celestial body changes their behavior. So the magnetic field of stars and other objects changes the path of the cosmic rays. So it makes it impossible for scientists to trace them back to the source. So this is the one thing, right? So they are hard to detect, but they are the direct evidence of where these rays come from. So we can determine the source. Now, high energy neutrons can escape very opaque environments in the universe. For example, they can escape area around the black hole also. Hence, it is important to understand them because neutrinos can give us information about the universe that no other observational method can give, right? So these are the properties of neutrinos because of which we are investing so much money to understand them. Now, again, connecting the dots, that means related topics: dark matter, IceCube second generation, India-based neutrino observatory, neutrinos in depth, if you're curious, standard model of physics, right? So the answer was, excuse me, the answer was D. It's 1, 2, and 3. So let's move on to the third question.